we'll talk about the motivation with regard to energy management options, show some application examples, and how can contribute to this energy management. So when I had this or started the preparation for this presentation, then I thought about, okay, thinking about a 60-liter diesel engine, 16 cylinders operating. So I thought, okay, what can be Ken's contribution? Therefore, I think it makes sense to have a look in that way. What does energy management mean? What is the motivation? And how can Ken support this? Briefly to my person, I haven't introduced myself yet. So my name is Zitzmann, hold a degree in electrical engineering. And in the meantime, I'm the general manager of the Ken Automation GmbH, which is the commercial arm of the association and 100% daughter of the association. So the main objective is of the Ken Automation GmbH to organize the association and to offer all the services that are intended by the association to its members. And so also if the members have any requests, that they can come to Ken Automation and get corresponding assistance. Yeah, as I've said, I will prepare some insights into, or give you some insights into this energy management options. And therefore, let's have a start with an insight to the motivation. Why do we have the motivation to handle the energy, to manage, to save energy? And one of the motivations can be derived from the EU Commission. We have in other concepts now heard that the EU Commission has some ideas with regard to cybersecurity, with regard to safety. Now they have also some ideas with regard to the reduction of greenhouse emissions. And in December 2019, the EU Commission announced the objective to make the EU climate neutral by 2050. So also the construction value chain that seems to be responsible for about 36% of carbon emission in the EU shall contribute to that objective. And although most of the emissions are generated in other regards, so for example, during generation of building materials, also the construction phase itself has to contribute, and this means also the construction machinery has to contribute to this objective. And as a result, we have to go to electric. And this is nothing new, by the way. So for example, already in 2016, Volvo presented a prototype of a hybrid wheel loader that provides up to 50% of improvement in fuel efficiency. And they are not the only one, and the earliest. I found also much older examples. So I see here illustration from the booth from Bosch Rexroth at a Bauma China fair, where they already depicted that they have developed energy optimized working hydraulics, so to achieve more productivity, efficiency, and automation. Though energy saving, energy management is just one aspect, and they want, as I've said, also to have a more efficient system, a more precise system, a more highly automated system. And the heart of this is the so-called BODAS system. So it's an abbreviation for Bosch Rexroth Digital Application Solution, an open, simple, accessible, and scalable ecosystem to manage mobile applications. And we see this here on this on this image. And the nice thing, Ken plays there a very important role. And if we go into the data sheets of the application, then you see there that J9039 is used, Ken Open is used, Ken Open Safety, and other things. So we see, okay, the good news is we need embedded communication, we need Ken-based communication here to allow this energy optimized networking for increasing the productivity, the efficiency, and the the automation. And Bosch Rexroth, they are not the only one. We have also others. So Uwe has presented also an example from Bauma. So we also work with CAN automation at the last Bauma. And there were several companies, in particular host controller manufacturers, responsible also for the entire control setup, such as a company Intercontrol. They depict then on their, so they exhibit it, and I derived from their website then some descriptions where they say, yes, we need embedded networking for CAN-based energy measurement, energy management, but also increase of the efficiency of the embedded control. And therefore they said, okay, we have a CAN bus control of the machine functioning, so the hydraulics, the electronic, and for that, we need also pressure sensors, the HMIs connected via the CAN. We need cameras control for controlling the surroundings. And if we go into the control specifics, then we see once again, a lot of CAN technology is used. The CAN is the important embedded control network, also in these applications. And once again, we see the already named higher protocols such as CAN Open, J9039, CAN Open Safety. And if we do not look only to the suppliers, but to the machine manufacturers, how do they think about energy efficiency, energy management? Then we see here the CAN-based applications are used here by company Bauer, for example, to allow this objective, the reduction of energy consumption on the construction site, as an ecological objective, as well as an economical objective. So this means in addition to the reduction of the emission of CO2 and other pollutants, the reduction of costs on diesel is a highly motivating factor to introduce here the CAN communication, to use the embedded networks and to increase the efficiency of the control of the machine. And you see here the statement given by Bauer with regard to their solution, the energy efficient power, or abbreviated the EEP. Solution contains numerous modifications to improve the efficiency, the drive system of the main winch, with a significant share in energy consumption, especially during a specific type of drilling. So this Kelly drilling was fundamentally re-engineered. So the new system makes it possible to recover the energy released during the lowering of the tool. So they do something, they have a kind of recuperation. So when they lower the tool, they can regain energy, and therefore they can save energy, they can reduce the fuel consumption, and they can fine-tune the control of the engine for saving the fuel at the end of the day. And we see this here as a result. They can increase the productivity by 10% with the solution, as they state. They reduce the fuel consumption by 30% and a significant reduced noise emission reduction of 50%. So we see everything enabled by CAN-based control, and the CAN, which allows the collecting of the sensor data to the delivering the data to the control and to the actuators. So summing up for the motivation, we have the reduction of greenhouse gas emissions. We have optimized control of process. We have increased the degree of automation. So as we have already heard in the talk about safety, there we have more and more autonomous operating machinery, such as self-driving machinery, for example, for road constructions, which are communicating with each other and operating completely autonomously, more or less the entire construction site, which leads us then to the digital construction site 4.0. So all these these trends are motivations for a higher digitalization, and this supports then also the energy management, measurement, and also in some shares needed the battery management. So this leads to embedded control networks such as CAN are needed. They allow then the embedded machine control and data acquisition. So we need this to feed the cloud-based applications. We have the energy management on the one hand to achieve the reduction of greenhouse gas emissions, and on the other hand, to increase the efficiency. And we need, of course, to meet with these embedded control networks future requirements. We have heard now about safety and security, and there may be some upcoming further regulatory demands. With regard to CAN, and in particular there with regard to CAN Open, we are very well equipped, as Holger has already shown, and I think also Uwe a bit, that Canon Automation is already offering a lot of specifications that are and profiles that are relevant for heavy-duty machinery. So we have the basic can open that gives us an idea where is our data, where is our data maintained device internally in a harmonized format. We know exactly how to access this data in a standardized way. And I think we do also a very good housekeeping in Can Open with regard to the Can identifier. So this is a little bit another handling as Uwe has shown with regard to J9039. So Can Open goes there another way. And we have there some extensions of the basic Can Open specification. There, in the first place, I like to mention the 302 that allows the network management, program download handling, thinking about redundant systems. And it covers also some ideas with regard to energy saving modes. I will say later on some words with regard to that. We have already heard where we find Can Open Safety. And if we want to embed our machinery into the cloud, maybe some devices, maybe the entire system, then we have the document 306 that allows the device description, that provides already a node list, that provides already functionality for browse names. So maybe I want to represent, not in a technical, but more in a user-friendly style, this entire machinery. And how to access the from the cloud, the machinery. This is described in the document 309. So we are very well equipped. And in addition to that, we are already hosting a document CiA 320, which is under review currently, which is dealing with power management. So there we can contribute with the functionality given in 302 or 320. We can contribute to the energy management in CAN-based systems as they are used in construction machinery. In addition to that, we have many documents for construction machineries defining some application-specific data. Uwe has shown this, so I don't want to go into depth here. And in addition to that, we have documents that are specifically designed for energy measurement and energy management. So I've already mentioned the document 302 and 320. And in addition to that, we have application data defined for the use case of the energy transfer. This may be a very simple transfer as given in document CiA 418, 419. And we have a power supply in 453. And we have a more comprehensive document for energy management, not directly written for the use case or having the use case mobile machinery in mind, but we will see it can be used for that use case as well. And finally, we have the document 458 that is applicable for power supply. Also, this can be used in certain applications, also in the environment of mobile machines. Let's have a short look to the different documents. So we have here the document 458 for energy measurement. So we see this document is what is given there. The functionality is applicable to very simple energy measurement. So total energy meters, resettable energy meters. We have so-called smart energy meters. So for example, for motor control units with several energy management values, you can see here, we can measure phase to ground, phase to neutral voltage. And we have here Also, the functionality described for complex devices that allow to support comprehensive energy management tasks. So where I measure for any of the phase of the lines, the corresponding voltage. So this is a very nice document where you see here the overall layout of data that can be maintained in a harmonized way in the CanOpen Object Dictionary. So like some um, parameters that give some idea about the origin, about the gauging of the device, and then finally you find the real measured values like the total energy meters. So this everything is given in a harmonized format. This means you can rely on that, and in particular in a measurement system where you have several contributors, you don't have to um, reprocess the data all the time to avoid misinterpretations, like Uwe has reported from J9039, but the representation of the data is very clear independently where you use this device for measurement. And the very nice thing is the profile is written in a way that it can be added to any device implementation. Either it's manufacturer-specific data that you maintain, or you have already maybe a device profile implemented. Nevertheless, you just use according to the setup of or the arrangement of data in the CanOpen Object Dictionary as introduced for long time ago in the CiA 301 CanOpen specification, that you have a certain arrangement of the harmonized data, of the standardized application parameters, and it's just one additional slot where you add now your parameters for energy measurement. And this means if you follow this approach, you don't have to modify current implementations if you want to add energy measurement, but you just add this in another so-called profile area. And it's just an addition for CanOpen device implementations, very simple to support. You see also we have here some power saving parameters as amendment to the communication parameters. So this is exactly what is derived from the 302 document. And there we follow an energy saving concept, which is derived from the so-called device degradation. So you may know this from your laptops, where you say, okay, if you don't touch your laptop for a while, the screen scales down in its brightness, then it's shut off, and over the time, more and more device functionality is shut down and reduced, and therefore you save energy. But to the network, it seems that your device is operating to 100%. And these kind of use cases we have also in the CAN world. So we have there the document 302-9 for energy saving. And this is applicable also in mobile machineries. That we follow this document that supports 9 energy saving levels, let's say. And there's an energy saving level 0, where you don't save any energy, you operate to 100%. But depending on the use case, you may step down or reduce your energy consumption up to level 8, that is more or less a sleep mode, low power mode, power down mode, something like that. So, and you have some manufacturer specific steps, and now you can say, okay, everything is manufacturer specific, so why should I support? That's only part of the truth, because I like to remember you on these additional parameters standardized in the CanOpen world, where you can say, okay, which kind of power saving levels do exist? How can I get to a certain power saving level? I can command them or pre-adjust them, let's say that way. When I set up my system, of course, I can also dynamically modify them, but in general, I would pre-configure them when I set up the system. And then during system runtime, my device can decide, okay, now I should go to a certain energy saving level. And some parts of my application can now save energy, mimic to the rest of the system that they are 100% working, show that they are available. and I can save energy while other parts of the system work to 100%. So this, you see, we support in the CAN open world, and there exists another solution or way of processing of energy saving. This is more or less the partial networking. So in contrast to the previous one, in the partial networking, we are more in the central point of the network. And from this point of view, you say, okay, now I want that my system goes into the low power mode. And if I need it again, because the mode of operation changes, then I switch the system back and it shall operate to 100%. So, and in the meantime, it shall save energy. And in addition to that, there may be also the use case that only shares of the system shall save energy because I need other shares of the system to operate for processing the current part of the application. And this is the so-called partial networking. Um, you know, in the CAN world, there are only modifications and developments come if there is a need in the automotive world. The automotive world wanted to save energy, and therefore they analyzed several use cases and said, okay, night vision I don't need during daytime, rear camera I don't need on a high-speed ride at the highway. So therefore we need partial networking, and therefore we have now available CAN hardware that supports this partial networking. So we have there corresponding transceivers that allow switching off the backline device functionality, so the real energy consuming functionality, and they can go themselves in a low power mode. So there exist two solutions. So since the year 2007, formally described in the ISO CAN standard -5, there we have those transceivers that allow a low power mode, support a low power mode, and if there's a communication on the CAN, then they wake up the backline functionality, and in the meantime, I can save energy. So this is a component, this CAN transceiver, that is suitable for applications where the entire control network goes into sleep and awakes more or less in a synchronized way. In applications where I need partial networking, where I say, okay, this, and this device has to operate to 100%, but others can sleep and can save energy in the meantime, then I need something that supports the partial networking, although that is available on a CAN transceiver level since the year 2013, internationally standardized, also formally in the part 6 of this CAN standard. And here I can program in the CAN transceiver a certain wake-up pattern, a certain wake-up frame, and I have a compare logic. And then depending on the frames, on the traffic that is on the bus, then my CAN transceiver identifies, okay, that's my data frame. I see here the right CAN identifier, that's my wake-up frame, and then it wakes up the backline functionality. Otherwise, the backline functionality can stay in the low power mode and can still save energy. So just for being clear, so don't search anymore for these old standards since the year 2016 and the upcoming of a CAN-FD and later on CAN-XL. Now all this functionality has been merged to the ISO 11898-2. So for you, it's now very simple. Just go for the current ISO physical layer specification and standard, and you will get this information about the partial networking, selective wake up, and low power mode. In general, having this partial networking, low power mode, and these things under control, it's not that simple as it sounds. So like now wake up, sleep. So it's in fact a very complicated task, because you have to analyze, okay, which devices have a similar wake-up sleep behavior, belong to the same kind of application, support at least all the requirements that you need, the attributes that you need for supporting this sleep wake-up mechanism. So in case of doubt, the capable CAN transceivers. And then you can cluster your devices and then you can manage them. But already this is already a challenging task, but there are more questions around this increased complexity. So, for example, from an application point of view, in which device state is a descent to the sleep mode, to the low power mode allowed? Who is allowed to indicate sleep mode objections and who handles the priorities? Who may say, okay, nice objection, nevertheless, we have to go to sleep now. If we have dynamic changing systems, how can I differentiate a sleeping system from a lost system? Who is allowed to awake systems? And finally, what means waking up? In which way do we wake up, similar to an unconfigured device, which may cause longer boot up times? Or do we wake up in a configured way, maybe directly at the working point where we fall asleep? So all these are questions. I have no general answer to all this, so you have to find your own answers in your applications. But the good news is, in CiA 320, for example, we try to handle a bit these questions and to guide you through a part of these challenges here. And in the document 320, we tried to cover this with something like a state machine, where we said, okay, we have the CanOpen state machine, and where or how does this wake up sleep behavior fit to this CanOpen device state machine? And we say, okay, after initialization, the device is in an alive state, and here it remains, it does fully operate till we have somehow the demand for going to sleep. Then we go into immediate state, the prepare sleep state, where we can see, okay, can we really go to sleep, or are there certain situations happen that would lead to a system state of uncertainty, which we have to avoid definitely, that a part of the system falls asleep, a part tries to wake up again. So we have to avoid these situations, and therefore we have this, let's say, secure state, prepare sleep. And then when we are sure, okay, all can now go to the sleep mode, we have the switch delay, another waiting time, and then we have the system safely in the sleep mode. And then we have also defined how to wake up. So we see now here the sleep mode handling. So therefore, the sleep mode handling, we have the power management manager. He is responsible for double checking that the entire system is somehow synchronized in the sleep power saving and wake up behavior. So we don't fall asleep single, but we do it always in a kind of synchronized way. At least this is our approach. So there we can say, okay, start with the prepare sleep command, ask for objections. If there are objections, keep the system in the prepare sleep. And if we then say, okay, now we can go to sleep, then set the system to the sleep. We have also the possibility to override objections with the set sleep command. And in other systems where we don't have a manager, for whatever reasons, it may be necessary to have then a timer-based sleep transition. Yeah, so CiA 320 allows, therefore, a sleep on command or dynamically go to sleep power management, and also the power manager. This is the instance that initiates the wake up. This is currently ongoing. So we have a version 1.0. We have now for about 2 years experience with the implementation. Nevertheless, we think now we can update the document. We are currently in charge of doing so. So if you have any comments, any requests, please come to the group, and any request, any functional enhancements will be appreciated and will be discussed. As I've said, we have already defined for power transfer, for energy management, and so on, data, application-specific data. So for the batteries, we have there, for the simple battery charge, we have there the documents for 18419. So these two profiles in combination, they specify a recommended practice for the communication link between a battery module and the battery charger. So the required communication is intended being sufficient to allow a battery charge being carried out. And you see here, on the one hand, you have the everything you need for this charge. In addition, you have also data relevant for identifying are the right parties talking to each other. It's maybe not that level what we would call today security, but I think it's a very good start for that. We have also the power supply. The power supply profile CiA 453 gives us also the possibility for let's say, for a more comprehensive power supply than we have with a charger in 419. You see here a much broader layout of the available parameters, and therefore we can ask the battery how the battery wants to be charged. Typically, the battery knows it in the best way, and then the power supply can provide a power supply as it is intended by the battery for having an efficient charge up to 100% of this battery. And finally, I have to accelerate a little bit. We have a very complex energy management system. It's the energy management system CiA 454 that has the objective of offering an energy management system that provides either central or highly distributed management of prioritized energy sources and sinks in a safe and reliable way. It had been written for light electric vehicles, has then been extended for stationary applications like isolated farms. But in general, it has now the option to manage all kind of energy sinks and sources. And therefore, it's very applicable also for mobile machineries. So you can have several energy sinks, you can have several energy sources, you can prioritize them. So what do I really need? What kind of sinks and sources are vital for my application? What kind of energy sinks and sources are just optional, nice to have, and then I can drop them to lengthen the availability of the key application. And finally, I have also for cloud applications and so on, a status register that indicates what's the current energy management status. So you find in my presentation slides then the catalog of all the data that is specified here for giving demand values, for getting the status. And you see here, CiA 454 is an entire profile family. So in particular of interest, I think is the generic load, the generic generator, and then the energy management. Yeah, summing up, electrification of mobile machineries, heavy-duty machines, off-highway vehicles, commercial vehicles, the state of the art. Hybrid or electrical drivetrains are used to lower the greenhouse gas emissions during construction phase. Embedded control networks allow to support comprehensive energy saving concepts. And we maintain CAN-open profiles suitable for heavy-duty machines. CAN-open device architecture combined with harmonized application data increases interoperability, eases system design, and simplifies embedding heavy-duty machinery into the cloud. CAN-open already assists system architects with several ready-to-use energy management and management concepts. And finally, we appreciate any support in form of comments, contributions, proposal for functional enhancements. So please submit them, or the best option, come to the group and present it and discuss and be part of the network, social network of CAN experts. Thank you for the moment.